We know now that this is a risky situation where there are different number of persons in the group. In this table we have taken from 13 to 2, and we have to bet by paying $400, and the statement given here is that at least two persons from the group are having same birth month. So if that happens to be true, then you win the amount $3,000, and obviously for taking that the cost which one has to pay is $400. Now here if 13 persons are there, then the probability of your winning the bet is 1, and so whatever is the amount to take the bet, one can take that because the probability of winning is 1. But if number of persons is lesser than 13, say even if it is 12, then probability of winning is very high, that is 0.99995, but still there is some probability of losing the bet. So now a decision is involved. How much amount we can pay to take the bet? If there is a risk, it doesn't mean that we will not take that risk. We will have to quantify that, and then based on the amount or based on the cost which we have to pay if that risk happens, we will be taking the call. So if we don't win the bet, then we will be losing this $400, and if we win, we are getting $3,000. So now here we have computed some expected value. This is by multiplying the amount, that is the winning amount, by the probability of winning. So if this bet happens several number of times, then over a long run you can expect to win this much amount per bet. So if you are paying $400 per bet, and if you are winning $250 per bet, that is the expected winning amount, then obviously we are loser. So in this risky situation where suppose there are only two persons and the statement is that both are having same birth month, and if that happens, then you win $3,000, and to take the bet you have to pay $400. Then the expected amount which you can win by taking the bet repetitively is $250 per bet, while you are paying $400 per bet. So it is not a good decision. But the moment you find that there are three persons in the group and at least two must have same birth month for you to win the bet, we are finding that probability of winning is 0.236, and if you win, you are winning $3,000. So if we multiply 3,000 by 0.236, then we are getting the expected value as 708.33. So if situation remains the same all the time, and there are three persons in the group, and to win the bet at least two must have same birth month, then over a long period of time, like taking the bet multiple times, you can be sure of getting somewhere around $708.33 per bet. And since you are paying $400 only for taking the bet, so you can expect to gain about $308.33. But yeah, still it is a probability. So 0.236 is the probability of you winning the bet. And based on the expected value, if you take a decision to take the bet, and if it is to be done just once or twice, then the probability of losing is also quite high. So it is just like tossing a coin. So you take the bet based on all these scientific calculation, and suppose you lose, then obviously that will be a poor decision. But scientifically, when we are taking a call here, we will be expecting that in similar situation we have to keep on taking the decision repetitively many times, and that is how we are going to manage the risk. And in that case, working with the expected value can be a very good tool. So now if we look at this table, say if there are 7 persons in the group, and to win the bet at least 2 should have the same birth month, then probability of winning is 0.889, and expected value is $2,665.8. So this is quite decent, and since we are to pay only $400 for taking the bet, this can be a very low risk kind of situation where the probability of winning is quite high, and the amount which we are paying to take this risk is also relatively very low, because the expected amount per bet is $2,665.8. It means that even up to $2,500, if one has to pay to take this bet, one can go ahead with this. So, understanding of probability and then the expected value can be such a good tool in taking scientific decision in a risky situation.